All right, very cool. So very happy to be here. Sorry to be the only thing between you and lunch. I'm hungry too. So I'll try to be quick and also informative at the same time, and hopefully just as fun. My name is Ray, and I just realized my USB stick is actually here, and so my remote is actually not working. There we go. So my name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is I'm an engineer who loves to bring some of the latest and greatest Google technology to developers all over the world. And I also like to hear about how you're using the technology today. I want to hear about your feedbacks and your comments and your questions. The best way to find me is actually on Twitter @Satanism. Okay? How many people know what that means? This is actually a real word. No? Anyone? No one. Wow. It actually means, I didn't know this. I've been using this name for the past 10 years or so. I didn't know this until maybe a year ago. Somebody told me it actually means lead poisoned. Now, that's not why I chose it. That's not why I chose it. If you want to hear the story, I'll come back later to it. Okay? So I've been in technology for a very long time. I've been in the industry for about 15 years now. And I've been doing a lot of the startups, and then moving on to enterprises and systems integration. I'm working in utilities companies as a client of mine, and also hospitality. And after that, I went on to another company where I did a lot of sales engineering. I did a lot of work with our customers. And now I'm working at Google as a developer advocate. But one of the things I noticed, wherever I go, whether it's a startup, whether if I wanted to start a new company myself, or a new project, a side project myself, or when I'm talking to the customer, one of the biggest problems is always about data. Data is sticky. Data is one of the biggest bottlenecks. There are a lot of problems around data, right? There's the problem of storing data. There's the problem of being able to query it, being able to have a data warehouse so you can get insight from the data. But a lot of things that a lot of time people kind of oversee or fail to see is the online transactions of data, right? There are many, many companies out there that's using, say, a SQL database of some sort. How many people use SQL of some sort? Oracle, MySQL, right? Postgres, right? There's a lot of that. Well, in many of these databases, there's always a bottleneck somewhere where you will hit a ceiling where you just can't query or store data anymore. Right? There's an upper ceiling in terms of how big the physical box can be. And so there are many ways around this. Particularly in MySQL, for example, you can have a shard, you can have a single master write, you can have multiple workers read. And in fact, I think YouTube actually used MySQL for a very long time, and that's what they have done. They have to shard the data, they have to create this infrastructure around MySQL just to make it scalable. Actually, some of those code is now open source. If you're interested in scaling MySQL, you can actually go to this website called Vitess, vitess.org or .io, I forgot which one. But if you go there, you see the actual YouTube database that they open source so that you can manage a scalable MySQL database in an orchestration tool like Kubernetes. And then we have another extreme where we go into NoSQL, right? NoSQL is web scale. How many people have seen that video? NoSQL is web scale, right? But what we don't see there is that, well, you have to remember, without the schemas, which is okay sometimes, you could have problems with the data integrity. And also, these NoSQL databases are eventually consistent. Because of the CAP theorem, you always have to give one or the other, with consistency, availability, or partition. And for NoSQL, they are able to provide a lot of the availability through sharding and partitioning, but they're eventually consistent. And then what I've seen in another extreme is that seriously, I heard this a couple weeks ago. Another company, they're saying, well, we have to do everything in Cassandra. I'm like, why? Well, because it was a mandate. We need to be very, very fast. But what type of system is this? Well, it's an online transaction system. I'm like, well, how do you deal with transactions? Well, they're like, well, we have to write a layer on top of Cassandra to deal with transactions. I'm like, oh my God. Right? But the key here is that you gotta understand the data and what you're trying to do and be able to decide the type of technology that you want to use. You don't want to just use one thing just because you heard it's faster, right? And Google had a lot of time and experiences dealing with data, coming from all of these papers that you may have seen before. All the way back to 2003, we had the paper on GFS. This is a way to store a lot of file system data on distributed file systems. And then we have MapReduce paper that everybody knows now, through the usages of Hadoop, right? And then we got Bigtable, the real ones that we wrote papers on, and such. We have so much things. But many of the things are now part of the Google Cloud Platform. And I can go on and on here, but I don't want to take a lot of time. But the one thing I want to you to kind of focus on is Spanner. And that is actually one of the latest database technology that Google has been using. And now it's actually something that you can use on Google Cloud as well. And it is designed as an RDBMS that is horizontally scalable. How does that work? It's actually a relational database that you can use. You can have real schemas and everything, strongly typed tables and fields. And also, you can run SQL queries on it. And it is fully transactional, so it's ASIC compliant, and with a global consistency. What that means is, because this is a globally scaled database, what that means is not just having one instance of Spanner instance that you use. In a Spanner deployment, you can actually have a database that's spanned across multiple zones in the same region. Or in the future, we'll have a global deployment where you have Spanner instances all around the world in different data centers, but they're still the same database. And when you do a write, when you do a read, we can actually guarantee the consistency in those operations, spread across multiple instances. Now, this has probably never been done before Google has been doing this, right? And the best part of it is that because this spans multiple zones, for example, or multiple regions, and that is how we actually get a lot of availability out of it, right? I think there's, like, if I remember correctly, 5 nines of availabilities today when you deploy this globally. So what does that look like? One thing I want to mention in this one is just that we've been using this for the past 5 years, and it started off with ads, of course, right? So the takeaway on this particular slide is that when you're looking at different database options, right, we have the traditional relational, we got the NoSQL on the other end, right? They all have their pros and cons. What Spanner wanted to do was that, at Google, we still needed to process online transactions. And we, of course, have multiple choices of the internal technologies that we have, but they actually went out and built this new thing that is not only able to handle the load, but also being consistent. And the way that works is that when I deploy this Spanner deployment, I can specify how many nodes that I want to have. And each of the Spanner node can handle up to about 10,000 reads per second, and also 2,000 writes per second. That's just one node. If you ever need to handle more, you can just spin up new instances. And when you're doing these writes, unlike some of the other database systems where you do have to have a client, for example, that you need to understand how to shard the data, you need to physically deal with the sharding and replication of the data yourself. In Spanner, you have this one single connection to the service, for example, and we will take care of everything else behind the scenes. That means rather than you needing to, say, understand which node to write to, through this connection, we will automatically route the writes to the leader of this system. And the leaders are being elected through the Paxos systems that we have. And once you do the write, the data piece will be automatically synchronized to, or replicated synchronously to the other nodes in the cluster as well. So let me just show you one of the things that you can do. So for example, I'm going to go here and so just for fun, I'm going to go ahead and show you this console. This is the Google Cloud Console. And from here, I can probably create a new Spanner instance. I'm going to say my demo, maybe. OK. And I'm going to create 3 nodes, for example. And if I look down the performance guide, we actually tell you how much read and write each of the nodes can handle. So I'm just going to go ahead and create this instance and see how this works. Oh, let me zoom out and create. Make sure all the information is correct. Oh, yeah, of course, I need to select a region. So I can put it in the US Central or Europe or Asia. So let me go ahead and create one. See how this works. All right, that was pretty fast. So now I have a Spanner instance with 3 nodes. Now I can go ahead and create a database. I know previous talk we talked about Fluxfix, is that right? So I guess I'll code this Spotify. No, I'm just going to code music. So rather than dealing with movie, which somebody already did, I'm going to deal with just music. And for this, I can add a table. And you can go through this GUI to do that. But I like to use text. And so in this UI, what I can do is I can create the table via DDL. And this is pretty familiar for many of the people who used regular databases before. So I can create a table called singer. I can have the ID and the name, and I can create another table called albums, which is actually nested, right? This is a master-children relationship, right? So from the albums, I need to reference to the singer ID. Now in Spanner, there's no concept of, say, foreign keys, right? There's no foreign keys. We cannot apply foreign key constraints. But for these parent-children relationships, what we can do is that we can specify an interleave. Okay, this is important. What that means is that when the children data is being stored, it knows that it belongs to which parent. And through this definition, what we can do is we can co-locate the parent and children data onto the same node. Remember, this data is going to be partitioned across multiple nodes here, right? So when you do, say, a join, what you want to do is to make sure that the data between the parent and children are located physically together, so you can do the join much, much faster. Okay? So I can go ahead and just create the tables, and that should be it. Right? Pretty simple. And then what I can do is I can go ahead and query the data. Right? So I can, for example, here I can create a Java application. Let's see which one is this one. Yeah. So I have something written here already. We actually have a client library that you can use, and you can create the Spanner instance. You can get the service. This is like a little object that you can operate on. And then you can get the database client. And from this client, what you can do is to specify which database do I need to connect to. So I'm in the project's called CFGCP, and I just created a new instance called my demo, and then my database is called music. Right? So from here, I should be able to connect to this database via the database client. Now here's the tricky part. In Spanner, out of the box, from the client library, we will be able to, say, allow you to give us a SQL query. We can run the reads. But for the writes, we actually have to write these mutations. Okay? In Spanner, the transaction semantics is a little bit different from what you'd be accustomed to. Right? In Java, you have JTS and all that. In Spanner, we will need to enforce transaction based on potentially time. Right? This is one of the magic behind the scenes is that we have atomic clocks in our data centers that can assign the timestamp to when the write or the read actually happens. And based on those timestamps, we can guarantee certain consistency. So in order to do a write, what we need to write is, like, say, a mutation. And from this mutation, I can say, oh, I need to insert something. Let me insert it into the table. And then I can set, for each of the fields, I can set the value to it. So here I'm adding a singer called Michael Jackson in this case, and I can do the write, and I can write multiple mutations in a batch if I want to. And finally, if you want to do the read, you can also read from the database client, but we also provide a JDBC driver. However, the JDBC driver is only read-only at this moment. Okay? So you can specify a JDBC driver, and you can give it the connection string. Let me update this as well. I'm going to say this is my demo, and I'm using the music database. And I can select star from singers and all that. Okay. So with all that being said, let me see if that actually works. Uh-oh. But I'm going to stop this application, and whew, live demos, you just don't know, don't you? All right. Oh, there we go. OK, so this code actually works pretty well because I wrote it before, which is fine. But if I go back to the console, if I go back to the Spanner console, and I can do a query, and from here I can select star from the singer, and I can run the query, and I can see the entry is actually there, right? Now that is all pretty good. I mean, not bad, right? That's not bad. But I do miss something here. Personally, I did miss a few things here. Most importantly, I missed the fact that there's no ORM. I need to write these mutations myself, or at best, right? How many people here actually write a lot of SQL queries today to do the inserts and updates? Oh, yeah, it's only a few people, right? A lot of us just use ORM. And there's JPA, there's MongoDB for Spring Data in the previous example as well. So actually, I was working with Josh on this for 1 week in Chicago a couple months ago. And I said, Josh, it will be really nice to be able to do this demo with Spring and with something that's a lot easier to use. And Josh said, are you sure? Do you want to go down a rabbit hole? How many people here have written your own ORM before? No? I tried it before, and I know a lot of the things is going to be pretty hard. For example, how do you know which objects, which classes needs to be managed by this ORM system. How do you map the fields between the object or the class versus the actual fields in the database? So I had options there. I had options. It was really late in the evening. I had options of writing it myself, or I can use Spring Data and Spring Data REST. Now, the reason here is because I can actually I can write all of these things myself, but why do that when, for example, Spring Data already has the metadata systems all in place? So all I need to do is to follow the rules, and maybe I can get this thing out pretty quickly. So what I've done is I created the Spring Data project for Spanner just for fun, and for myself to learn how everything works. And the key here is that everything surrounds a mapping context. This is really the key. From the mapping context, it will be able to extract your classes based on certain annotations or whatever. Based on those, you can extract this class and make it a persistent entity. And that is a metadata class that is very important in this context. And from this persistent entity, you can extract and iterate through all of the properties that's defined in the class, and we can extract the actual properties. For example, the IDs and columns and all that. And it is very extensible, so I was able to define my own annotations that maps my POJO directly to Spanner constructs. And that was really useful. And once I have this mapping context in place, which can create the metadata out of my classes, then I really need additional facilities to help me map from my class through the metadata and into the actual mutations that I showed you, right? So this is a one-way mapping from a class to the mutations for operations. And finally, on the way back, when I do the read, I can use the JDBC reads, which will give me the result set, but I can also use the native client library to do the read, and that will give me what we call a struct. A struct is just basically a row that has multiple fields or properties or attributes, however you call it. And so I had to create a struct to object mapper that takes the structs to the actual POJO. And once all of these three things are in place, and I can put them together into the templates. How many people here actually have seen or tried to open up, say, a Mongo template or a JDBC template or a JPA template in Spring? I think we use it all the time, but we really never really opened it up. So this was my chance to open up one of these templates and see what's actually inside. And it was actually quite simple. You need the mapping context to figure out the metadata. You need the mappers to map from one to the other, to the POJO, or the POJO from the way back to the actual operation. So through the Spanner template, with these three constructs, I am now able to take a POJO, annotating it, and say, go through the same find and delete and all the CRUD operations. So let me show you what that looks like. Okay. So I am going to actually do something. How much in the mind? I got like 5 minutes, right? All right. So no, 20. Okay. Wow. Well, that's a lot more than I expected. Well then, let me show you what I got. Okay. So just for fun, this is what I'm going to do. I think that Josh and Mark did a fabulous job showing some of these live coding. So I'm going to take that step and hopefully not fail too bad. OK, so I'm going to go ahead and create a new project. And this is going to be a REST repository with Lombok and JPA and HSQL right here. So I'm going to generate this new project. I'm going to download it. I'm going to open this up. OK. And then let's just see, where is it? Where did it go? Data demo. I'm going to go in there. I'm going to open up the pom.xml. OK. And from here, what I can do is potentially, I'm just going to go through a few setup here. So what I'm going to do is I'm going to create this class called Singer. Okay. And with JPA, what we can do, which is we can say entity, right? And then we can have our ID. I can annotate the ID, and I can make this auto-generated. So I'm going to say generated value. And then I'm going to have the string field code name as well. Okay? And I'm also using Lombok because it saves me time. I'm just going to say data, and maybe a toString so I can print it out later. Okay? And this is pretty easy to do. And from the client side, what I can now do is to get a JPA template, and I can do all the CRUD operations I want. But that's probably not enough, right? what I need to do, for example, is I'm going to create a repository as well. So I'm going to say single repository. And what I want to do is to also show exposing this endpoint on the REST endpoint. So what I'm going to do is I can add this REST resource. And this is not a class. It needs to be an interface. And I can extend the JPA repository. This is what we do today, right? And I can give it the entity type, which is Singer, and the ID type, which is long. So I can do that. And with any lock, today, if I go to my terminal, and hopefully if I do Spring Boot run, gonna do that, I should be able to see the CRUD interface right here. Okay? So, but this is how we do this in JPA, right? And we're already seeing something that we are doing with MongoDB as well. But let's make this work, and I'll show you how I can convert now very, very easily to run this on Spanner. And once you do this, then you can actually deploy this application at a different scale, right? Because now we can deploy this onto a scalable database. So let's try it. So I'm going to go ahead and go to my local host and see if that Singer, oh yeah, whew, that was too easy. All right, so we got the Singer's endpoint, right? And I can go ahead and see what's there, and there should be nothing. And of course, if I really want to, I can create a JSON document to potentially add a new entry here. So I'm going to say this is a singer.json. Okay. In this JSON file, I'm going to just say name is equal to, I don't know, I don't really listen to music. Who else should I put here? Daft Punk? Anyone listen to Daft Punk? No? Not in this room? Oh, wow. They're awesome. I love them. All right. So once that's done, I can just go ahead and do a curl. And I can do a post. Give the header of content type is equal to application JSON, right? And I can give it the data file, which is singer.json. And I can give it the URL I want to post to, which is localhost 8080 and singers. Oh, not bad. So just with this few lines of code, right, I got this whole REST thing going on. And if I go back to my URL, I can actually see what's there. And now I have a full CRUD HTTPS compliant endpoint. That was really easy. Now, if I want to, it wouldn't be nice if I can just run Spanner in the same way. And that is what I have done with Spanner data REST and Spring Data for Spanner. So what I can do instead is, for example, rather than using data JPA, I'm going to delete that. I don't need that anymore. I don't need the SQL database here either. And what I can do is, all I want to do is to depend on my Spanner starter. Boom, that's done. Okay. By the way, all the source code is on GitHub as well. And because Spanner uses GRPC behind the scenes to talk to our services, and if you don't know GRPC, it is a RPC framework that Google and other companies have open sourced. It is actually now owned by the Cloud Native Foundation. So it's a very efficient RPC protocol that we're using both internally, and whenever you talk to one of the cloud services, we're also using GRPC to talk to our services behind the scenes. Now, the only trouble here is that in GRPC, it actually implements HTTP2 stack natively. And to do that, we had to use TC native. And to do that, we had to use Tomcat components inside. And Spring out of the box actually uses Tomcat extensively, right? So we have the Tomcat starters and all that. Now, the trouble here is that they will actually conflict with each other. So what I want to do then is to have an exclusion here. I need to exclude Tomcat from my deployment here. So I can say, let me exclude my Tomcat starter, Tomcat. And then I can add in the Jetty starter, which doesn't have the conflicts that Tomcat has. Okay, so I'm going to say starter Jetty. Okay, done. That's all good. And just gonna make sure I refresh this a little bit. And now you can see all my JPA stuff is gone. And what I can do is say, rather than having a JPA entity, I'm going to have a table. This is going to reference to the Spanner table that I just created. I'm going to say name is equal to singers, for example. And these two ID fields and generated value is gone as well. what I need to do is to use the Spring's own ID annotation that kind of marks this as the ID field, and that is actually what's being used by Spring Data REST later. And also, there is no generated there's no generated values in Spanner either. We don't have auto value generations for your IDs. Right? In MySQL, in many of the databases, you can generate based on sequence. But in Spanner, if you do it that way, it's actually a bad practice because the data is being partitioned. If you have a monotonically increasing or decreasing key, what is going to happen is you might actually create hotspots in your database. Okay? And what that means is that as you're increasing the key values, the data is actually not being distributed to multiple Spanner nodes in this case. So it is actually recommended that you create your own key that has a meaning, or you use, say, UUIDs to create the keys. And even if you use UUIDs, you still have to be careful. There are actually multiple versions of UUIDs. In UUID v1, it's very much based on timestamp. And timestamp is, again, monotonically increasing. And that will actually create hotspot. What you want to use instead is maybe UUID v4 instead. Okay? So I can just go ahead and map this to singer ID. And I can map this to singer name. Ooh. OK? And then what's interesting is, well, how do I actually configure this to be used? What I can then do is to create the application properties. I can say Spanner project ID is equal to CF GCP. Spanner dot instance ID is equal to the one I just created, which is my demo. And then finally, Spanner dot database is equal to music in this case. Okay? Now, this is interesting as well, because even if I created the Spanner templates and all that, the other thing that I have to consider is how do I make sure people can get started quickly? And this is where the auto configuration and starters come in place. And it took me a little time to understand the power of this auto configuration. Because by default, right, with every of the Spring modules that we use, by default, there is some kind of object that you have to instantiate. Whether if you're using programmatic configuration, then you're gonna create a bin that says configuration, and then you have to inherit something, and then that's how you configure the spanners or JDBC or JPA or whatever. But to make an auto configuration, what we can actually do is to make some assumptions. So the things I just entered in application.properties, the way that it's being retrieved is actually by using this Spanner properties class, which is annotated with configuration properties with the prefix of GCP Spanner. So now, all of these attributes in here will be automatically extracted from the properties file. With that prefix, it's going to get mapped into these fields. And once you have these in the properties object, then we can actually enable my auto configuration that reads directly from the properties file, and I can have some assumptions of where they are by convention, and then I can create a database ID that is what's necessary to connect to Spanner. And to tie this thing all together, the last important part of making your own auto configuration is by adding this spring.factories file in meta-inf. And in this factory file, you have to actually say, you have to have this key value pair. The key is going to be enable auto configuration, but the value is actually the auto configuration class that you created, which is that one. So now, if I ever include my auto configuration dependency, Spring is going to pick up the configuration through this spring.factory file. It's going to instantiate this class and then also load the properties, and now everything's connected. And with it, I also get my Spanner templates and everything else. Okay? Whew. So far, so good? All right. So now, if I go back to my demo app, and if I do a clean, and if I rerun this thing, hopefully this will work. Let me see the time. Oh, wait, what? What just happened? Oh, yeah, sorry. There's a few things I need to do. Yeah, not yet. I'm not there yet. So remember, we use JPA repository here. Rather than doing that, what I need to do is to use a Spanner repository instead. So I can just do that. Oh, sorry, not Spanner template, Spanner repository. Okay. And then what I can do is, in my demo application, I'm going to enable the Spanner repository. I'll tell you how this everything kind of hooked up in a second. Okay. And let me try this again. Whew. It's too scary. Okay, so far so good, but it doesn't mean it runs. It just means that it started, but we haven't connected to the database yet. Now here's the moment of truth. If I go to the RESTful endpoint, oh, that's good. That's relief. So I can see this, the repository stuff is being picked up by Spring. If I go to singers, and I see Michael Jackson here. Now I wonder why is that the case. Let me just do one more thing here. I'm going to do a Spring clean, and then do the run again. Okay. Okay, so let's see. Did I get rid of, I think I also I have to get rid of SQL as well, which is gone. Yeah, okay, let me try this again. Do the refresh. And they're still there. Okay, well, that's not bad. What's that? You already saved that in the database. I did save that in the database, didn't I? Yeah, I think I did, yeah. So that's probably why that's still there. Okay, very good. So now, with a few changes, I'm actually able to, create this repository directly from the Spanner source. Now, the key there is actually here. Okay. Now, with Spanner data, it's actually a very sophisticated infrastructure or architecture behind the scenes for us to process all of these metadata for you to create this ORM-like environment. And the way I started, if you ever want to try this yourself, the way I started is I started from Spring Data Mongo, right? MongoDB. I thought, hey, MongoDB is a NoSQL. If we can do this in NoSQL, we can probably do this in Spanner as well. So I started from there to figure out all of these navigations. Now, the last thing that I had to do, and unfortunately this is why, it's because Josh was like, well, you know what? Just the template is not enough. Having the template wasn't enough, so I had to create the data REST stuff. Okay, and to create the Spring Data REST connections, what I really needed to do is to dig even deeper into the rabbit hole and figure out, how do I actually connect some of these things together, specifically the CRUD operations where I need to do the finds and the deletes and all that. And once I figure out how these things are implemented and marshaled into the proxy, then Spring Data REST will pick up everything else. And the high level is what it looks like. We have repository registrar. That is something that will be picked up by the context automatically. And from this registrar, I need to register what we call the configuration extension. And that doesn't do much except to give you a repository factory bin. What that means is that if given a repository interface, like the one I just showed you, the Spanner repository interface that I extended, what actually needs to be the backing code that we need to proxy in order to serve the data. Okay? So it is actually in the repository factory bin that you have to be able to say, this is the factory bin, this is the repository bin I want to use. And once you have this all tied up, then whenever I have this interface, it's going to instantiate the new repository bin for me and add this into the proxy. So whenever the code comes in to do the find, it's going to invoke my bin instead. So that is actually all of the magic behind these things. Now, if I were to open this up, if I say, here's the Spanner template, and you can see there are quite a few classes I had to create, okay? And here's the registrar, and here's the factory bin. Okay? And this is actually just the factory bin. What that means is actually create a factory. So it's one of those factory stuff, okay? But what's important here is that once you get to this factory, this is the key. This is actually the key to tie everything up together, which is this one method, which is get repository base class. And based on different annotations or based on different behaviors, we can actually return a different type of implementation class. And so far, the only thing I implemented is the simple Spanner repository, which means that we can get CRUD operations out of it. We can also get pagination and sort out of that as well. And behind the scenes, we're turning all of these magics of the REST repo and also the existing Spring ecosystem, which is tying this into the Spanner semantics instead. Okay? So let me go back to this slide. One thing I did learn quite a lot about Spring Data is that it was actually easy, very easy, to extract the metadata from classes. If I were to do this myself from the scratch, I had to deal with, say, inheritance, right? If I have multiple layers of inheritance, how do I actually traverse the tree up this inheritance structure to figure out which fields are actually mapped? Or with Spring Data, it actually does all of these things for me automatically. And all I need to care is which entity class am I dealing with, and automatically it's going to extract all the properties of the tree for me, and also all the annotations associated with all the columns and stuff like that. The other thing that Spring Data provided me was the ability to identify a field as ID. As you saw in the Spring Data REST, it was keyed by a single ID. And you key this ID in the URL, for example, and that ID annotation is the same across multiple Spring Data implementations. So once you identify that ID field, right, everything else kind of just follows. And then finally, the abstraction is created for pagination, which is something I always wanted to just like, every time I need to implement pagination, it's just really, really hard. I had to start from scratch. The abstraction for pagination was actually quite straightforward. It gives you the sorting that's necessary in the pageable object. It also gives you the offset and the limits of the current page that you are on. And then from those three things, you can then extract the count, which is the total number of pages, for example, and also being able to query the right set of data based on the page that the user is on. Now, there are a few issues, though, that still need to be resolved. For example, there is no transaction. The transaction semantic in Spanner is a little bit different. So what that means is, it's not really tied into the whole JTA semantics, right? In Spanner, if you want to do transactions, you have to wrap it around a runnable, and all the instructions in the runnable are guaranteed to be run in the same transaction, but it doesn't really propagate into the JTA transaction level. And there are things that we're thinking about to make that a little bit better. And also, the IDs that we talk about, here's the problem. Here's the biggest issue that I had so far, which is that in Spring Data, it's typically made to deal with a single ID, right? We always have a surrogate key, and that is something that we've been using for years now, right? Having a surrogate key has been pretty easy. It's always auto-generated, but it also contributes to the scalability problem. If you have an auto-generated key, first of all, we can't really shard it easily, and secondly, it's going to hit an end. So what we recommend is that in Spanner, what we want is to have these composite keys. And that is actually a little hard and difficult to implement in Spring Data today. So that's something I'm hoping to be working on later. So with all that said, hopefully you learn a bit about Spring Data and also about Spanner, something that you may want to take a look and try. And if you want to see how all the code, how everything works, and see the demo of this on your own computers, for example, you can go ahead and go to my GitHub. I have a Spring Data Spanner demo there. And you can also get the Spring Data Spanner example project, so you can try this out. And if you want to contribute, please let me know. And last thing is, at the beginning I said the JDBC thing only has read-only support at the moment, right? And we're committed to have some kind of DML support in the future. And once that's done, you could potentially tie this in really, really easily with any other JDBC-oriented ORM, and that should be pretty awesome. So thank you for your time, and thanks for having me here. Thank you.